What is iron? What is steel? And how do we actually make them? If you've ever looked at a skyscraper, a car, or even your kitchen appliances and wondered how a raw chunk of rock becomes something so strong, so essential, you're not alone. Iron and steel are behind some of the most important inventions in human history. In fact, the development of these metals was so revolutionary that entire eras were named after them. The Iron Age marked the moment when humans unlocked the power of one of Earth's most abundant elements, and from that point on, nothing was the same. Iron gave us tools, weapons, machines, and with steel, we went even further. But how do we actually get from raw ore to industrial might? Let's start from the beginning. Iron ore. It's basically a rock pulled out of the earth that contains particles of iron trapped in chemical compounds. To extract the metal, we need to break those bonds. This process is called smelting. But before we had factories or electricity, early humans used simple forges. These were small, charcoal-fired setups, powered by a steady stream of oxygen from a bellows. Charcoal, nearly pure carbon, reacts with the oxygen in the iron ore and releases it, leaving behind metallic iron. The result? A hot, spongy lump of iron and silicates that was hammered to remove impurities. This was wrought iron, tough, flexible and ideal for tools, nails and weapons. But the story doesn't stop there. As technology advanced, we built taller furnaces and used powerful air blowers to get even higher temperatures. That changed everything. Now the iron could fully melt, separating into layers inside the furnace. At the bottom, you get molten iron, rich in carbon, but brittle and hard to shape. We call this pig iron. And while it's too fragile to use directly, it's the base material for something even better, steel. Steel is made by reducing the carbon in pig iron to precise levels and removing impurities like sulfur and phosphorus. The result is strong, flexible, and endlessly useful. The true backbone of modern civilization. And there's more. By adding small amounts of other metals during the steel-making process, we unlock even more possibilities. Want something rust-proof? Add chromium. That's stainless steel. Need something light but strong? Add molybdenum. From electric motors to spacecraft, these steel alloys are everywhere, and while we've experimented with aluminum, carbon fiber and high-tech plastics, nothing matches the cost, strength and versatility of iron and steel. Not yet, anyway. That's why nearly everything around you, buildings, cars, machines, even tools in your garage, are made with them. So next time you pick up a pan or pass by a train, remember, it all started with a rock and a fire. Let's go back in time, way back. Archaeological evidence shows that blacksmiths in the Middle East were already smelting iron as far back as 2500 BCE. But it would take over 1,000 years before iron became the dominant metal in the region. Why? Because early forges just couldn't get hot enough. To produce higher quality iron, blacksmiths needed better furnaces, more heat and more control. Over centuries, technology evolved. By the 1300s, European smiths had developed taller furnaces and manually operated bellows that could generate enough heat not only to soften iron, but to melt it. This was a game changer. It laid the groundwork for the invention of the blast furnace, a towering machine that remains the foundation of modern iron production. Today's most advanced method of smelting iron is done inside a blast furnace. This giant structure is loaded with three main ingredients: iron ore, limestone, and either charcoal or coke, a purified form of coal. A huge volume of air is blasted into the bottom of the furnace, fueling an intense chemical reaction. The limestone, rich in calcium, bonds with impurities like silicates and forms a floating byproduct called slag. Beneath it, the real prize collects: molten iron. Periodically, this glowing liquid iron is drained from the bottom of the furnace and poured into sand molds, where it cools and solidifies. At this stage, the product is known as pig iron. To make just 1 ton of it, you'll need 2 tons of iron ore, 1 ton of coke and half a ton of limestone, all heated to a searing 1,600 degrees Celsius at the furnace's core. But here's the twist. Pig iron, though rich in iron, contains 4 to 5% carbon, making it extremely hard and extremely brittle. In that state, it's almost useless for practical tools or construction. So what do we do with it? We refine it. There are 3 main paths. First, blacksmiths can reheat it, mix it with slag, and hammer it repeatedly to force out most of the carbon. This creates wrought iron, malleable, strong, and ideal for tools. The second option, melt the pig iron down again, mix it with scrap metal, burn off some impurities, and cast it into molds. This produces cast iron, which contains 2 to 4% carbon along with trace elements like silicon and manganese, perfect for shaped products like machine parts and cookware. But the third option, that's where the magic happens. We push the refinement process even further to create steel. Steel is iron that's been purified, most impurities removed, carbon levels precisely controlled between 0.5 and 1.5%. Impurities like silica, phosphorus, and sulfur weaken the metal, so they must be eliminated. One method to do this is the open hearth furnace. In this system, pig iron, limestone, and sometimes more iron ore are heated to around 871 degrees Celsius. The limestone binds with impurities to form slag, which floats on the surface. Oxygen then reacts with the carbon and impurities, drawing them out. When the carbon level is just right, you've got carbon steel. Strong, flexible, and ready for action. And it doesn't stop there. Once you've got carbon steel, you can add other metals to customize its properties. Want it rust resistant? Add 10 to 30% chromium and you've got stainless steel. Want something light and strong? Add chromium and molybdenum to create chrome moly steel. These blends shape the modern world, from kitchen sinks to jet engines. And think about it. Can you imagine life today without steel? Look around. Bridges, phones, bikes, buildings. It's everywhere. Let us know in the comments what steel-made item you use the most. And hey, don't forget to like this video, subscribe to the channel, and hit that notification bell so you never miss a dive into the fascinating world of science and industry. Big hug, and see you in the next video.